So, what could be the plus you bring to?
Hello, my name's Adam. I'm an intern here at STEM, and I'm working on the Juggling Balls project. And the part of the project I'm working on is mapping the different sensor data, and so that we can recognise different gestures or different actions. And then I'm also programming the audio engine that we'll use. Well, not programming the engine, it's a library for Arduino so that we can have all the audio produced from inside the juggling ball. So I'm coding the mappings and the audio.
My name is Eva, and I'm doing internship in physical computing. So my role here is to make a documentation of these modules in a black box synthesizer made in the 70s by people first time. And I have to make a documentation of it, which is very challenging because the modules are really complex and it's got lots of components. And it's like Christina described this as like playing chess in 3D, three-dimension chess. It's really intense. But I'm doing my things too. So here is a ring modulator which didn't work, and it's based on a ring modulator built by guys from Stein. So this is the one which doesn't work. So I decided to make the other one, this one, which is less complex, and it was working, and now it's stopped. So I need to, I think because the wires are touching each other. So that's the thing. And now I'm working on a weird sound generator, which is designed by Ray Wilson. This is it. And if you want, I can show you the schematics which I've done. This thing is envelope generator. It looks really complex. I think because there were big beginnings with. I just started doing this stuff, and so it looks a bit complex. And I need to remake it so it's more clear. But this is basically this thing, envelope generator. And it's 40 years old. So, and that's the ring modulator. This one.
My name is Nick, and I'm intern here, and I'm working on some physical prototypes for the juggling balls projects. Basically, what I do is to, starting from the circuits, I design some shapes with a 3D modeling software, and then I usually print them with a 3D printing machine, which is there. So actually my job here is to think about how the shape of these projects must be thinking about usability and how it's easy to use, how it's easy to fix, to open it, etc, etc. And at the moment I'm developing, as I say, these juggling balls, and I already made some prototypes, like starting from the basic one, which is this. It's very simple. It can hold just a piezo and the mini B we are working with, and that's it. Afterward, I made this prototype, which is able to contain, of course, mini B and piezo, but also a speaker and a switch and a charger. So actually, for the jugglers who will use this object, they will be able to charge it and switch it on and off without opening it. And next step I'm gonna do, what I'm working on with my software. I normally use, for this project I'm using Rhinoceros and SolidWorks, two 3D modeling software. And what I'm doing now is to lay on the ball surface a conductive part. So actually the ball can detect when the juggler holds it. And we have two concepts. Basically, the first one involved the use of some conductive silicon, which is been ordered and we are waiting for it. but actually since might be a problem to stick silicon with silicon, since here there is a silicon layer. I'm also working on a sort of rail that can contain some copper tape. This rail, like you see there is a little offset in this part, so in this little rail there will be some copper, so or some other conductive material, also because like copper does oxidate very fast, so we will probably have to find another way, but copper or any other conductive material should be alright.
My name is David Enthoven and I work here in the research and development part of STIM, and I'm currently working on the juggling ball project, for which I design certain circuits, and right now I'm testing different amplifiers for the optimal sound quality of the juggling ball.
Hi, I'm Jasper. I'm an intern here at STIM, and I'm working on the development of a platform for Rosa, which is a live sampler, and we want to put this sampler within a black box system, so you can plug it into the power and connect several interfaces to it and have your live sampler working without having troubles on the PC, such as updates, system updates, etc. And I'm doing it with the help of a big board, and I'm currently working on. I already created a IDE and a development system for of a development environment for Rosa, and I'm working on the connection, the OSC connection, the Open Sound System connection in between the interfaces, such as a Arduino, which I have over here, or other interfaces.
Yeah, I'm working on gesture recognition with the accelerometer sensors on the SenseStage. Yeah, so I'm teaching computers to learn gestures online and classifying them at the same time. What's supposed to be happening is that I do a gesture a couple of times, the computer recognizes it, and then put some event, couple some event with the gesture, and then you should hear something. So if I'm circling with my hand a couple of times, it's recognized. I hear a specific sound, and I don't do a gesture, and it dies away again. And if I do some other gesture, another sound is triggered, and I can stop again and do the first gesture again. And kind of thing that's cool about this is that the gestures is not a predefined set of gestures. You can think of your own gestures while you're doing this, and the computer learns them on the fly. So yeah, that's pretty much it. It's not fully tested yet, but that's what I'm working on.
So I'm Raiba. I'm doing part of the research and development team of STIM. I'm working on a couple of different projects. Right now I'm experimenting with some sound design for projects for an object which you can fiddle around, and then it should make some sound. So got a small setup now where if I stop moving it around, it will keep making sound. If I stop, the sound will slowly go away. I'm mainly in charge of hardware research. I've been working on wireless sensing. I'm not sure what to tell more right now.